For my next project, I decided to try out what feels like a rite of passage in robotics, building a balancing robot. Now this is something that's been done many times before, so I wanted to focus on a few design constraints to make my build a little more unique. First, I wanted to keep everything compact. This is in contrast to most two-wheel balancing robots that tend to be taller to increase their moment of inertia, making it easier for them to balance. I also wanted to have a clean, friendly design since most balancing robots end up being a couple layers of exposed electronics spaced out with standoffs. With these goals in mind, I'm happy to present Tic-Tac, the two-wheel balancing robot. For components, I wanted to use NEMA 17 stepper motors and my Microbot control board, so that dictated the overall form factor of the design. The body of the robot also had to house a battery, the voltage regulator, an inertial measurement unit for balancing, and an ultrasonic distance sensor. To get Tic-Tac to balance, I'm using an inertial measurement unit to determine how far it's tipped from an upright position. Then I drive the speed of the motors proportional to this tip angle to maintain balance and prevent it from falling over. Controlling Tic-Tac is done by changing the balance point for front to back motion, and by equally increasing the speed of one wheel and decreasing the speed of the other for turning. For being my first balancing robot, I'm really happy with how Tic-Tac turned out. I think the design really achieved the simple, friendly aesthetic I was going for, and the balancing ended up working fairly well too, without even needing to use a full PID controller. Tic-Tac can balance and stay in one spot, and it even holds up against some light impacts. One area where there's still some room for improvement is the directional control. It certainly works, but it isn't as smooth as it could be, since when driving at higher speeds, there's an oscillating motion. If you'd like to build off this design yourself, the CAD, code, and PCB files are available at my GitHub, linked in the description. Let me know in the comments if you have any thoughts on improvements or ideas for any other robots I should build in future videos.